In this video, we're going to take a look at the three methods we have for solving quadratics. We'll talk about which one should you use based on the equation you're trying to solve. And then we'll take a look at the benefits of each different form of quadratic equation. All right, we'll start with what are our three methods. We have factoring, completing the square, and quadratic formula. Factoring may be the easiest, especially if you can solve the diamond problem. If you can't solve the diamond problem, then you don't want to do it. One bad thing about factoring is it doesn't always work. Next up, completing the square. This is best to use when the b value is even after you divide out the a value. Unlike factoring, it always will work. And finally, quadratic formula can be used when the other two methods are not good options. Although we will be solving quadratic equations in this video, if you need detailed instruction on how to use each method, you need to look at my previous videos on how to use each method. Go ahead and pause the video and try to solve this on your own. When you hit play, you'll see if you chose the same method that I did. So the first thing you should notice about this equation to make your life easier is all three of the numbers can be divided by 2. Anytime you can divide out a common term, you should do it because it makes everything much easier. So this leaves us with 2x squared minus 3x minus 14. Now, if you can factor it, that's usually the easiest way to solve these. But since they don't always work, you might want to do your diamond problem off to the side. This one, 28, the first thing you should think of is 4 times 7. 7 minus 4 gives you 3. So we can solve this diamond problem with a negative 7 and a positive 4. Since we know it's possible, let's go ahead and set up our box diamond, and we already know our answer for the diamond problem. Now we can place those in the box. So now we got to figure out where the 2x will go to get our 2x squared. And notice that the greatest common factor of the 2x squared and 4x in the column is where the 2x goes. So you got 2x times x gives you 2x squared, and you finish it off with a positive 2 and a negative 7. Again, if you want to see more details on how to solve these problems, watch my previous video on it. From here, we can write our factored form. Then we use zero product property and set each factor equal to 0. And then we just go ahead and solve both of these and get our answers. You could have used quadratic formula to solve this one, but your numbers would have been much bigger. You probably would have been pulling out a calculator at some point. You can always complete the square, but on this one, when you divide out the 2, you would have been left with fractions, and you don't want to complete the square when there's a bunch of fractions involved. So in this case, factoring was our best option. The more you practice, the better you get. So go ahead and pause the video and try to solve this one. And then when you hit play, you can once again see if you chose the same method that I did. Once again, look at all three numbers and check and see, is there something that we can divide out? And in this case, everything can be divided by 3. So that always leads to smaller numbers and an easier problem. So let's check factoring by doing a diamond off to the side. There's only 2 ways you can multiply and get 15. 1 times 15 and 3 times 5. And since it's a negative 15, you can't subtract and get 8. So this would be a situation where factoring will not work. So that leaves us with a choice of completing the square or quadratic formula. Since the b value is a negative 8, that's an even number, which we can easily split. So the easiest way to do this one would be completing the square. So we'll go ahead and set up our equation and group our x squared and negative 8x together and leave a space for completing the square. Then we'll set up our box and split the negative 8x into our negative 4x's. Now we can do the outside of the box. And then when we multiply negative 4 times negative 4, we complete the square with a positive 16. That goes back into our equation where we left the space for it. And then the a value now is 1. So technically we're going 1 times positive 16 which is positive 16. So the opposite to balance it out would be a negative 16 on the outside. And don't forget, this is all equal to 0. Now we can go ahead and simplify this to our vertex form of x minus 4 squared minus 31 equals 0. Let's write that one more time and start solving it. We're going to move our negative 31 to the other side where it becomes positive. And when we take the square root of this, 31 is not a perfect square, and it cannot be simplified in any way. So the last step is just to move our negative 4 to the other side where it becomes positive, and there's our answer, 4 plus or minus radical 31. You could not factor this. You could do quadratic formula, but it would be harder, the numbers would be bigger, and at the end, you would have some work to try to simplify the quadratic formula answer to get it down to 4 plus or minus radical 31. So the best method for this problem is completing the square. All right, next problem, go ahead and pause the video and give it a try, and then see if you solved it the same way that I chose. First off, I notice with an a value of 1, there's no way I can divide out a common term. So let's see if we can factor it by setting up our diamond problem. The only way to make 7 would be 7 times 1, and that doesn't subtract to give us 9. So this cannot be factored. So now I'm looking at the b value of a 9. Since 9 is an odd number, if I split it, I would get fractions, and that makes completing the square kind of difficult. So this would be an equation where your best choice is quadratic formula. So we'll write down what our a, b, and c values are, and now we go ahead and substitute those into the quadratic formula. From here, we start simplifying, and we're left with negative 9 plus or minus the square root of 81 minus 28 over 2. We simplify one more step, and we get negative 9 plus or minus radical 53 over 2. There's no way to simplify radical 53, so this is our final answer, and quadratic formula is definitely the best method to solve this one. The next thing we're going to do is take a look at the 3 forms we have for quadratics, and we'll talk about the benefits of each one and how you would graph for each one. So we're going to start with factored form. One way to represent factored form would be this, where r, s, t, and u represent numbers. To make this quadratic, the r and the t in this one could not be 0. There's another way that we could show factored form, and it could be this way, where once again, a, p, and q just stand for numbers that would be put in. We always use the a for our a value, and it could not be 0, and the p and q could be anything else. So the main benefit of having factored form is that you can use zero product property to solve for x-intercepts. Or if it wasn't about a graph and you were just solving for x, if you're given factored form, it's quick and easy to solve because you can use zero product property. If you have factored form and you want a graph, you would start by plotting the x-intercepts because you can get x-intercepts from factored form so easily. Next up, for any graph, you need to know your vertex. So the x value of the vertex is actually the midpoint between the x-intercepts. So that would give you the x value of the vertex, and then you would just evaluate this to get your vertex. So if you have your vertex and the x-intercepts, you can go ahead and graph your parabola. Next up, let's go ahead and take a look at vertex form. Vertex form is a times x minus h squared plus k. The main benefits of having vertex form is that you have the vertex, hk. You can also have the line of symmetry, which is x equals h. Vertex form is also the best one to graph with because you have the vertex. And then from the vertex, you can use the a value to plot the rest of the points. The last form of quadratics, and the most common one given to us in problems, is standard form. Standard form is ax squared plus bx plus c, and in this case, a cannot equal 0. The main benefits of having standard form are that you can always use the c value to get your y-intercept, which would be the point 0c. The second benefit is it's ready for quadratic formula. And before we look at how to graph, let's take a look at quadratic formula. Quadratic formula can actually be broken down into two useful parts. You have negative b over 2a. That gives you the x value of the vertex. It also gives you your line of symmetry. And then you're also left with the b squared minus 4ac part. And this will tell you how many solutions there are. If b squared minus 4ac is a positive number, you will have two solutions. This also means you have two x-intercepts. If b squared minus 4ac equals 0, that means your vertex is on the x-axis and there's only one solution. And finally, if b squared minus 4ac is negative, that means there are no x-intercepts and you would have imaginary roots because the square root of a negative would give you an imaginary number. All right, let's take a look at how to graph. So you're going to use the negative b over 2a part to get the x value of your vertex. And then you would have to evaluate this x value to get your vertex. Once you have the vertex, you do have the a value from the standard form, and you can use that to plot the rest of your points. And that will conclude our video on which method you should use and the three forms of quadratics.